Okay, guys. Well, as you saw in Mr. Walker's lesson, I would love to tell you this is easy today, but this is a little complicated. So what we're doing today is we're using reasoning by looking at benchmark fractions to compare fractions on a number line is what our standard is today. So our benchmark fractions today have changed. Yesterday they were 0, 1/2, and 1. But today's benchmark fractions, we've got 1 and 2, and then 1 and 1/2. Because as you can see, the numbers we're looking at today are more than 1, because we know 3/3 is 1, 6/6 is 1, 12/12 would be 1. So these are more than 1. So all of these are going to come between 1 and 2. On this first part here, what I've got for you today is like I did yesterday. I'm giving you two choices. So would this number come between 1 and 1.5? Or would it come between 1 and 1/2 and 2? So that's going to be your two choices on this first part, and then another part. So we're trying to decide, are they come up with these fractions on the number line? Would they fall in between here, or would they fall in between here? And so this 1/2 again is going to be key as we're reasoning, okay? Because all of these are going to be 1 and something when we look at them and we decompose them like Mr. Walker did. They're going to be 1 and something, but we've got to see if that something is less than 1/2 or more than 1/2. And we'll be doing that the same way we did yesterday. So let's decompose this 4/3. How many thirds do we need to make a whole? 1. We need 3/3, right? And we've got 4/3, so we have 1/3 more. So we have 3/3 and 1/3. 3/3 plus 1/3 would be 4/3. So this is 3/3 would be 1. So 4/3 is the same as 1 and 1/3. Now the question is 1 and 1/3 here or 1 and 1/3 here? Okay, this is where we've got to compare 1/3 to 1/2. Okay, so let's think about half of. This is get me confused too. Let's think about the denominator, thirds and halves. If we do thirds, then I've got to split this number line into 1, 2, 3 pieces. 1, 2, 3. So 1/3 is going to fall over here on this number line. And this would be 2/3. And this would be, really, it's 1 and 1/3, 1 and 2/3. And this would be 1 and 3/3. Okay? So 1 and 1/3 comes between what? It comes between 1 and 1 and 1/2. Like I said, this is just a bit confusing. You have to use the number line. You have to reason it out. If this had been an even number, we could compare it easily like we're going to on the next one to 1/2, but we can't really do it when it's an odd number on the bottom. So we really need to use the number line and draw it out for problems like that. The next one, like I said, is a bit easier. So let's decompose 11/6. To get the 1, we've got to have 6/6. And 6 plus what would give me 11? 6 plus 5. So 11/6 is really 6/6 and 5/6 more, or it's 1. This is 1 and 5/6. Okay, so now we're asking ourselves the same question. Does 1 and 5/6 come between 1 and 1/2 or between 1/2 and 2? Well, I hope since we did this yesterday, you're looking at this and you're already saying, Mr. Helton, 5 is more than half of 6. So it's going to come between 1 and 1/2 and 2. Because if it was 3/6, it would be right at 1 and 1/2. But it's more than 3/6, so it's going to be over here somewhere. So the answer to this one is going to be between 1 and 1/2 and 2. It's going to be that because, remember, 1 and 3/6 would be the same as 1 and 1/2. And this is more than 1 and 3/6. It's 1 and 5/6. So it's going to be over here somewhere. If we split this number line into 6, it would be more than halfway. Because 3/6 would be right here. Okay? Let's look at 17/12. Let's decompose it. How many twelfths do we need to make 1. Well, we need 12 twelfths to make 1. And 12 plus what would give me 17? I need 5 more, wouldn't I? 12 plus 5 is 17. So this is made of 12 twelfths and 5 twelfths. And, of course, we know 12 twelfths is 1. So we have 1 and 5 twelfths. All right, so thinking about halfway, because we're looking at this number line, thinking about what 1 and 1/2 would be. If we're looking at twelfths, what is half of 12? It would have to be 1 and 6 twelfths to be 1 and 1/2, because 6 is half of 12. This is less than 6 twelfths, so this is going to be on the number line. Since it's less than 1 1/2, it's going to be between 1 and 1 1/2. So the answer to this one would be between 1 and 1 1/2. 1 1/2. This is tricky, I know. But what the purpose of this lesson is, remember, you're using benchmarks. You're thinking about 1 and 1/2 as your benchmark. This is what we're comparing everything to. This 1 and 1/2. Is it less than 1 and 1/2 or more than 1 and 1/2? So that's why we have to look at this fraction and think of equivalent fractions. So 6 twelfths would be 1/2. And so this is less than 1/2. So you got to think about it like that as we're doing today. There's a lot of problems again today. So I'm going to work them with you as we do these problem sets. Then you'll have them all obviously to do on your own. So the next one is 1 and 5/6 and 1 and 5/12. Now on this one, we know that 3 would be half of 6 and 6 would be half of 12. So this is more than half of 6. This is less than half of 12. So obviously we can look at that one and see 1 and 5/6 is more than 1 and 5/12. Remember, twelfths would be smaller pieces than 6. So 5/12 would be smaller than 5/6. All right, this one we've got 1 and 1/3, comparing it to 1 and 5/12. All right, well, on the number line, we know that 1 is less than 3 and 5 is less than 12, but it's hard to do like this. So what we have to do is think about this denominator. If we can make this denominator the same, we know the ones, you can pretty much cross them out on a problem like this. What can I multiply 3 by to get 12? That way I can compare them. I can multiply 3 times 4. 1 times 4 is 4. So 1 and 1/3 is the same thing. It's equivalent to 1 and 4/12. So which is bigger, 1 and 4/12 or 1 and 5/12? Obviously 1 and 5/12 is bigger. That's the best way I know to show you how to compare these. You can draw them on a number line like Mr. Walker did if you want to. But if you can find that common denominator, get the same denominator on the same side, that's the easiest way to look at it right now. Okay, now we're going back to these kind. So we've got to decompose and see if they're more than 1 and 1/2 or less than 1 and 1/2. So 11/8, let's decompose it. Obviously, we need 8/8 to be 1. How many more do I need to get 11/8? I would need 3/8 more. 8 plus 3 is 11. Okay, so now I have to think about this. I've got 8/8, 1, and I've got 3/8. So 1 and 3/8. To be 1 and 1/2, I would have to have half of 8 would be 4. So 1 and 4/8 would be at 1 and 1/2. This is less than 4/8. This is 3/8. So it's less than 1 and 1/2. So my answer on this one is it would be in here somewhere. So it would be between 1 and 1 and 1/2. Okay, it's not bigger than 1/2. It's less than 1/2 is why we chose that. Let's look at our next one here. We've got 7/4. Let's decompose it. So 7/4 would be 4/4 to equal 1. And then we need 3/4 more to get 7/4. So this one we really have, I'm going to put it up here to save a little space. We have 1 and 3/4. Okay, there's 1 and there's my 3/4. So on this number line, I know that to be 1 and 1/2, it would have to be half of 4. 1 and 2/4 would be 1 and 1/2. this is bigger than 1 1/2. This is bigger than 1 2/4. So it's going to be over here somewhere because it's more than 1 1/2. So this one's going to be between 1 1/2 and 2. It's going to be between these two benchmarks. This one, 15/12. Let's decompose it. I need 12/12. And to get 15, I would need 3/12 more. 12 plus 3 is 15. So remember, this would be 1. 12/12 equals 1. And 3/12. Look at our number line. To be 1 1/2, it would have to be half of 12. It would have to be 1 6/12 to be equivalent to 1 1/2. We don't have 6/12. We only have 3/12. So that's going to be over here somewhere. So this answer would be, since it's not more than a half, it's not equal to a half, it would be between, what's it between? It's between 1 and 1 1/2. Okay, that'll be your choices. Remember, one of these two will be your choices on your homework today. Let's keep working. We've got to compare some more fractions. These get a little bit trickier. If you're going to draw them on the number line, you can. Let's look at finding a common denominator too. And some of these can be hard. So 11/8 and 15/12. 11/8 and 15/12. So what's a common denominator for 12 and 8? In other words, what are 8 and 12 are both factors of what number? What can I make on the bottom that I can make these equivalent fractions? Well, 2 times 12 is 24, and 3 times 8 is 24. So I'm going to make them both 24ths. So how do I do that? I've got to do 12 times 2 is 24. So 15 times 2, well, that's 30. 3 times 8 is 24. 11 times 3 is 33. So 11/8 is the same as 33 24ths. 15/12 is the same as 30 24ths. So is 30 24ths or 33 24ths bigger? 33 24ths. So 11/8 is greater than 15/12. I wish there was I wish I could just say, hey, it's not hard. Just figure it out. But you really have to work and think at these and come up with a denominator that's the same. If you don't, it gets really confusing to try to figure out which one's greater than. This is where you just have to put some work into it to find the answer. Drawing it on a number line, that's great. To use those benchmarks, that's great. But sometimes it doesn't always work out that way. Okay, if we want to break them down and like we were doing before and think, is it between 1 and 1/2? Maybe that would help us. But look, 3 is less than 8, so it's going to be less than 1 1/2. 3 is less than 12, so it's going to be less than 1 1/2. So you can't really tell. If you draw them on the number line, well, we know 12ths would be smaller pieces than 8ths. So we know that this one's actually going to be bigger because 3/8 would be more than 3/12. But if we want to go ahead and make this 3/8 and 3/12 have a common denominator, we know they're both got a 1 in front of them. What can we choose? Well, we did up here, 8 and 12. We could choose 24ths again. Get a little crowded here, sorry. 12 times 2 is 24. 3 times 2 is 6. 8 times 3 is 24. 3 times 3 is 9. So we've got 9 24ths and 6 24ths. So 1 and 3/8 is bigger than 1 and 3/12, which we already knew, didn't we? Let's keep going. Okay, 3/8, 7/12. All right, now we've not got numbers that are bigger than 1 on these, do we, for some reason? Well, again, make them a common denominator. We keep having these 12s and 8s. Let's make them 24s again. 12 times 2 gets me 24. 7 times 2 is 14. 8 times 3 is 24. 3 times 3 is 9. 9/24 and 14/24. 14/24 is bigger, so 7/12 is greater than 3/8. Now we've got 5/12 and 7/8. Okay, now let's just use some reasoning on this one. Sometimes, and we could have done it on this last one too, sometimes we can use that reasoning and just think about it. 5 is less than 12, so 5 would be less than 1/2. 7 is more than, I said that wrong. 5 is less than half of 12. 6 is half of 12, and that's less than that, so it would be less than 1/2. Half of 8 would be 4. 7 is more than 4, so this would be more than 1/2. So that would be greater. Okay, down here, 8, 6, 11, 12ths. Okay, well, 8, 6, that's more than 1, isn't it? Because 6, 6 would be 1. Is 11 12ths more than 1? No, it's not all the way to 1. So 8, 6 would be bigger than 11 12ths because 8, 6 is bigger than 1. Moving on. 5 12ths and 1/3. Okay, we can't think about the half benchmark because they're both less than half. So when it's like this, 5 12ths, 1/3, you could draw them out on the benchmark. We could think how many 12ths is 1/3. I said draw them out on the benchmark. I meant draw them out on a number line if you wanted to. Or we could do it this way. 3 times 4 is 12. 1 times 4 is 4. So an equivalent fraction for 1/3 is 4 12ths. So 4 12ths or 5 12ths, which one's larger? 5 12ths is greater than 4 12ths. Having trouble talking today. All right, moving on. 7 5ths, 11 tenths. They are both bigger than 1. What if we made them both tenths on the bottom? Let's change that 5 into a 10. 5 times 2 is 10. 7 times 2 would give me 14. So 14 tenths or 11 tenths? 14 tenths is bigger than 11 tenths. So 7 5ths is bigger than 11 tenths. You can make an equivalent fraction with the same denominator to solve these like we're doing. 5 4ths or 7 8ths. Which one's bigger? Well, 5 is larger than 4. So this is greater than 1. 7 is not 2 8. So we'd have to have 8 eighths to be 1. So that one's bigger because it's more than 1. You getting the hang of it? Like I said, this is one of the harder lessons we've done this year. We're going to keep working and thinking about these reasoning still. 13 12ths, we know 13 12ths. 12 12ths would be 1, so that's bigger than 1. 10 tenths would be 1. It's not there. So 13 12ths would be greater than 9 tenths because this is larger than 1. 6 eighths and 5 fourths. Less than 1. 5 fourths is greater than 1. So 5 fourths is greater than 6 eighths. 4 fourths would be 1. 5 fourths would be 1 and 1/4 more. 8 twelfths. 8 fourths. This is less than 1. This is more than 1. It's actually 2. So that would be greater than 8 twelfths. Last one. So many. 7 fifths. 16 tenths. That's bigger than 1. That's bigger than 1. So our last one, we've got to figure out, my goodness, we've got to make it a common denominator again. So 5 times 2 is 10. 7 times 2 is 14. So an equivalent fraction for 7 fifths would be 14 tenths, which is smaller than, less than 16 tenths. 16 tenths is the bigger one. Guys, like I said, it takes some work today. You've really got to sit down on paper, work these out, find some equivalent fractions with the same denominator if it helps you. Draw them on the number line. Think about it. Use reasoning if you can. Whatever helps you find that answer, just put the work into it today. you're not going to be able to do this unless you put the work into it today. Today is just today's assignment is just one of those times where you have to think and put some work into it to find the answer. Again, draw it on a number line if you don't understand anything else. That would probably take the longest. Reasoning is the easiest, but you can't use just reasoning on every single problem. Sometimes you've got to find an equivalent fraction to see which one is greater. So whichever of those three methods you need to do to find the answer, do them. Please don't guess. You didn't learn anything if you just guessed. All right, put it to practice. I believe you can do it. We'll talk about it in our Google Meet today. See you then.